So we're going to talk about parameter, area, and volume of some shapes like rectangles, triangles, maybe some spheres, cylinders. Okay, so we're going to start with some basic shapes like squares and rectangles. Okay, so for this one, let's do a rectangle. So rectangle, as you know, looks something like this. Let me see if we can find the shape here. All right, so this is a rectangle here. It has two sides, two dimensions, 4 sides. So we call this this is the length, or the longer side, and the other side is the width, okay? And these two are parallel and they're equal also in length. Same thing with these. So we have L and L here, W and W. So we can actually write it this way. Okay, so this is a flat shape. It's flat. It does not have volume, okay? In other words, you can't contain, let's say, air or gas or water into it, or a liquid, because it's flat, okay? It has to be in the form of a box or a sphere or a cylinder in order to have a volume. So these flat surfaces do not have volume. They only have perimeter, which is the distance all around the shape, and the area, which is the inside, not the volume, okay? For volume, we need 3 dimensions. For area and parameter, we need a flat surface with maybe 2, 3, or more dimensions. All right, so let's find the parameter of this rectangle. So the parameter, again, like I said, is basically just the addition of all the sides, the distances, okay? Just distances around the whatever shape it might be. In this case, it's a rectangle. So symbol for parameter is P, then equal sign, and you're just gonna go around the box. We're gonna add L to W to L to W again. And that's it. For instance, if this was, let's say, 5, what would the side of this, what would be the length of this side? If this is 5, this will also be?
Wow.
5.
Right, it will also be 5. So this will be 5. And let's make this one, let's say 3. This also be 3. All right, so to find this again, I'm just going to add all of them. So P for parameter is 5 plus 3 plus 5 plus 3. You can add 2 at a time. Then you could say 16, but we need a unit, 16 watt. So we need a unit that measures length. That unit could be inches, could be feet, could be meters, could be miles, depending how big the shape is. But we choose an appropriate unit based on the size of the thing. So let's say you want to measure you have a small rectangle, for example, in the shape of a dollar. You want to use inches, not feet or miles. That's out of proportion. But if you want to use, let's say you want to calculate the parameter of, let's say, Central Park, assuming it has a rectangular shape, then you'd want to use miles and not meters or feet. So this is the closest to it. Okay, so at the end, you want to put your unit. So 16 inches. For example, here, let's assume this is a small piece of paper in a rectangular shape. So we're going to say 16. And the symbol for inches is IN. For feet, you can say FT. For meters, the symbol is M. For miles, symbol is MI. Okay, so whatever the shape might be, so remember the parameter is basically just going around the box, just the distances, not the inside. The inside would be called area. If we take another shape, whatever it might be, 1, 2, 3, 4. Let me see if we can find the shape here. Okay, I don't have an octagon. 1, 2, 3, 4, 5. I mean a pentagon. So this one has 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is the shape of a pentagon. So when you count these heads, we have 1, 2, 3, 4, 5. That's an octagon. If it has 8, it's a pentagon, and it depending on how many. Of course, this is a rectangle with 4. It could be also a parallelogram. And of course, when it has 3 sides, we call that a triangle. So 1, 2, 3, 4, 5. 5 sides in this case. This is a pentagon, approximately. And usually the pentagon, let's assume all these are equal, all these distances. Let's say, for example, 3. So what would be the parameter of this pentagon? Parameter, basically just going to add this 1, 2, 3, 4, 5, or just multiply 3 by 5. 3, let's say maybe 3 feet. Times that by 5, you get 15 feet. Okay, so the parameter is pretty simple, straightforward. Just add up all the sides of any shape. Could be a triangle, could be anything. Just add them all up. Let's see. Let's now see how to find the area. Or before the area, let's do one more example with the parameter. Okay. A very common shape. That's a triangle. Let's say 7, 4, and 8. So the parameter, what's the parameter of this triangle? Everybody? What is it, or how to find it?
7.
And?
4.
7 plus 4.
Plus 8.
That's right, plus 4, then 8. Okay, that's 12. 7, that's 19. Don't forget the unit. It has to be a unit, for example, meters. So 19 meters. Every measure of something, of some quantity, must have a unit, whatever you're measuring. Okay, that's parameter. Now let's talk about the area. So the area, like I said, concerns the inside of a shape, the surface of it, just like for example, a room. So we're interested on the floor. The floor of a room has the area or the surface of the room. In other words, how many square feet or square inches is that room. If I bring another shape here. Okay, that's another rectangle. And let's, for this one, say maybe we got 5 here and we got 7. So we only need to write two sides. We don't have to write all the sides because we know this side is equal to this one is equal to this. So if I give you a shape like this, with only these two, that means we have another 5 here, we have another 7. Does anybody know or what the formula is for the area of a rectangle?
Length times what?
Exactly. So the area is the length times the width. That's your formula for area, but only works for rectangles. Okay. Each shape has its own. Each shape has its own formula for calculating the area. Again, we're interested in the surface here. the inside of this. Think of this as a room. How much space you have in that room, how much surface, or how many tiles or square feet, for example. Okay, the inside, not the outside. The outside distance is called the parameter. Okay, so let's find that out. A will be, in this case, as always need a unit. You gotta have a unit, let's say feet. So it's gonna be 7 times 5. So the length times the width, which is 35. And do not forget the unit. The whatever unit it might be, when you find the area, it has to be squared. So we say square feet. Or you can say feet, and you write the second power here. This is feet squared. Either way is fine. So square feet, or square meters, square meter, or square inches, or square whatever the unit might be, square miles. So in this case, the area is 35 square feet. So that's for a rectangle. Let's take another shape. All right, how does this shape look to you? Or what is the name of it?
Square.
Square. What's the definition of a square? How is it different from a rectangle?
They have equal parts.
That's right, all the sides here are equal. Here, each two opposite sides or parallel sides are equal, but this one, everything is equal. So usually we just write the length of one side. We don't have to write all the other ones because we know that they're all going to be the same. And the question will indicate that. You can't assume from the shape unless the question assumes that or says that this is a square. All right, so what is the area of this square?
Long.
It's length times width. In this case, they're all the same. So we can say, if this was, let's say A. Okay, A equals 9. I mean 3. Or actually, let me use a different letter so we don't confuse with the area. Let's say call this side B, or simply S for side. Let's say this side is 3. What is the area? What's the area if this was the
12.
9.
9. Okay, we need the area, not the not the perimeter or the parameter. So in this case,
They have 4 sides. That's why I said that.
yeah, so we need to times the length and the width, which is basically the same thing here, the same side. So this will be 9. And again, we need some unit, for example, meters. So this would be 9 and square meters, or m to the second power. Don't forget, the area is always squared, whatever unit it might be. So that's A, the area. What is the parameter? P of this square?
6.
It's more.
Not
Maybe.
6.
Oh, you add all the sides?
13.
We add all the sides, right?
Uh-huh.
That would be?
6.
12.
9.
12, that's right. 3 plus 3 plus 3, which is 12. This is a parameter. Do we need to square the unit for parameter?
No.
No, just write meters, just meters. 12 meters. Okay, so area, just multiply the two sides. This works for both rectangle and triangle. And for parameter, we just need to add all the sides all around the box. So the area is inside, the parameter is all around. That's for rectangle and triangles. Rectangles and squares. Now let's go to square. Let's do a triangle.
Excuse me, teacher. Can you repeat, please, square?
I'm sorry, repeat that.
Can you repeat, please, the example square?
Okay, so the square, all the sides are equal.
Mm-hmm.
Everything's equal. So the area is always times one side by one side, 3 times 3. Or if you have a rectangle, multiply the length by the width.
A square is just 3 times?
No, it's 4.
3 parts? Yeah, okay.
It's
So
4.
why is 3 for 3?
So all the sides are equal in a rectangle. In a square, all the sides are equal. This one is 3, 3, 3, and 3.
So 5 period 3. What is this?
I'm sorry, repeat that. This one here?
No. Up just you write 5 period 3 in a square example.
This one?
No, down.
Here. There is no 5 here. There's just 3s. 3 times 3 is 9. Here I have 3 plus 3 plus 3 plus 3. This.
This. Mm-hmm.
Yeah, I have 3 here.
3. I had 5 and 3.
There's no 5. It's 3, 3, 3, and 3.
Oh, okay.
All
Thank you.
equal.
Wow.
And all of them we get 12 meters.
Mm-hmm. Is A is squared, no?
That's right. The area always square the unit. Whatever the unit is, it's got to be squared. The parameter, don't square it, just write it. Miles.
Programmer is P.
I'm sorry.
What is the letter P? E. This. No. It's okay. Down is okay. Ahí.
P.
What is the letter?
P.
P. Yes. Okay. Thank you.
Or parameter.
Okay. Thank you.
Okay, triangle. So square. Now let's do triangle. So we're gonna insert triangular shape. Luckily, I have one here. All right. So this is a triangle. It has 3 sides. Let's say. Okay, it doesn't have to be. Let's say we have maybe 5 here, 5 and 7. And we're going to try to find the area, or the parameter. We already did the parameter here. But then when you have a triangle, just add all of them to find the parameter. But for the area, we have a formula. So the area of a triangle is like this. It's B, the base. This is the base of the triangle. Let me write it this way, probably here. And we need the height as well. So the height of a triangle is basically this distance. When you drop this vertically, and you form a right angle here. So you drop this point here vertically. So this is what we call the height. Okay, H meaning height. And this one here we can call the base. So you can say the base, or the side that the triangle is sitting on. This is the base. If you flip it over and this one becomes flat on the surface, then this becomes the base. Okay, always have the base and the height, and these will be given to you. For example, this side is 5 and 5, so we need the height. For the area, we need the height. Let's give it, 6. So each shape has a formula that we need to remember. So for the area of a triangle, remember this, it's B times H divided by 2. Okay, base times height divided by 2. That's your formula. So next time you want to find the area of a triangle, the area, not the perimeter, the area, meaning the inside, you just need to get these from the shape. They will be given to you. What is B again for this triangle?
The base.
The base, okay, what is it?
H.
The value of it.
7.
That's right, it's given. So B
So B
times
times 5
times, not times 5.
times 6. 6. Yeah, 6. The height.
That's right, the height. And over
Divided to
7 times 6, 42 by 2. That's 21. And again, we need to have a unit. We can't just say 21 something. It has to be a specific unit. Whatever it might be.
meter.
Yep, meter, inches, feet. Let's use inches again. And what goes over here?
Time. Like
This needs to be
power 2. 2. I don't know how to say it. 2, yeah.
power 2. Or it needs to be squared. So the area of any shape is always squared. Whatever the unit is, has to be
squared.
Okay, so each shape has a formula. Basically, we need to remember those formulas. Or we can also, if you do the homework, they are in the book. For any shape, for any question, if you don't see the formula here, the book lists all the formulas. They have actually a page, I believe, the last page of the book has one, has all the forms with different shapes, with different formulas for area, volume, parameter. But we're gonna do a few of them here, and if you're anytime you need any formula, just check the book and you'll see it.
Professor, that's a 6 in the middle of the triangle?
Yes, this is 6 for the height. What else? Let's do one more shape, probably. Let's do a cylinder.
That's the one I had trouble with. Doing the homework. The chapter I think is 8. Not 8.1. The other one
Okay.
had the cylinder question.
Okay. So let's. Did you see the formulas in the book for the cylinder?
Oh yeah, they had it.
Yeah, right. Okay, before we get to, actually, we're gonna do cylinder later when we do the volumes. Okay, for now, we're just doing the areas and the parameters. For the volumes, we're gonna do the boxes and spheres and cylinders later. It's a separate unit. You're right, it's 8.7. What other shapes? That's pretty much the basic shapes here, at least these 3. And later again, if you need any other shape, you can find the formula for it in the book. Let's do, sometimes you have 2 shapes together into one, and the composite shapes.
A pyramid.
Okay, yeah, so composite. You said a pyramid?
Yes.
That's right. Yeah, pyramid has basically triangles all over the place, all around, and it has a base that's rectangular. Composite shapes is something like this. So you have, let me see if we can draw this. So basically, it has a weird shape. It's not regular, it's not uniform, but maybe, I believe I should use a different,
Oh, yeah, I know. Which one? It's like
use
a
these.
triangle
Yeah.
and then a square.
Mm-hmm.
I saw that one.
Let me use, for example, this instead. So that's a composite shape. As you can see, it's actually mixed up two shapes to come up with that one. Oops. So to find the area of this composite shape, we need to split it into two different shapes. But first, let's put some distances here. Let's say this whole thing is 10. Maybe it's a, so maybe we have a 9 here. And possibly 6 over here. And also, let's say 3 here. 3, maybe 7. So now this is, again, doesn't have a name. It's a composite shape. It doesn't have a formal name or a regular shape. And we want to find, let's find both. We're going to find both the parameter and area of this weird shape. So if you didn't have, initially you may not have this here. You may not have this line here. So we're going to split this into two regular shapes. If you draw a line here or this way, you can also draw a line this way to make two rectangles basically. And then you work with each one by itself, each rectangle by itself. So let's say you want to find the parameter. Let's find the parameter first, it's easier. So we're going to split this into first, so we have this first rectangle and this second one. Now, so to find the area, we need to find the area of both. So the parameter. So the parameter of this whole thing should be, let me try again here. Parameter 1 plus parameter 2, meaning this parameter and then parameter 2. Or actually, you know what? Let's just do it all at once together. So we split this into two rectangles. So the parameter will be this plus this plus this, 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 and this. All around, not the inside. We don't need this side for parameter. So first we need to figure out all the sides. If we have a missing sides, we need to complete all of them. For example, looks like we're missing this one. And we're also missing this one here and this one. So we need to complete all of them first. So this is known, this one, that one. This one is known. Now, is there a way to figure out this one? Using this and using this. What is this length, for example?
I think it's 6 or 10.
7.
So this whole thing is 10, right?
10.
And what is this one from just here to here?
6.
Same as this.
6, yeah.
6. So what's left here to make it 10?
3.
No. If this is 6, what's left to make it 10?
4.
4. Okay, so this is 4. So it's going to be the same as this one is 4. Okay, again, this whole thing is 10.
Mhm.
Up to here is 6, same as this. So what's left here is 4. So this one is 4. And these two sides are the same. So 4 here and also 4 here. But to find the parameter, we were missing this one and this one. This one I already know the whole thing is 10.
Then
We don't need to put a 4 here. Okay, so we know this, and this. Finally, we're just missing this one here. What is it based on what we have?
Is it
Oh,
9?
sorry, I don't understand.
So 9 is the whole thing,
Okay.
but we only need this piece, not all the way here. This is not part of the parameter. Parameter is just the outside, so we need this. So
Well, then that should be 7. That should be 3 because the top one is 7, right?
so this 7, this one is 7.
Can it be 5?
or can it be 2 less than 4?
Okay, let's see again. So we have 9 here. The whole thing here is 9. This one is 7. What's left from 9?
Oh.
2. So this one is 2.
Oh,
Because this is 7, same as this. And that's it. So now if you add them, so you have 2 plus this gives you 9. So we have all the sides now. So the parameter, you must include all the sides. So you'll be given a shape. Before you start adding, make sure you have all the shapes. So so the parameter is easy, straightforward, just add all around. So 6 plus 9 plus 10 plus, this 10 is the whole thing. So all the way here, 7 plus 4. And again, these 2, only this, not, we don't need the inside. This usually you won't see in the shape. I'll give you the shape, but it will not have this. So you have to split the shape first, either this way, or you can split it this way to get 2 rectangles. What is the sum of all this? We need a unit, let's say feet, for example. What is the sum of all this? So you can add up all these sides. Okay, so let me use a calculator just to save time, but usually you would do it on the side, showing your work and everything.
33, I think.
33, I get more than that. Let me try again. You got 38. Let me double check. Okay, so that's 38. Don't forget the unit. Do we need to square the parameter?
no.
That's right. Just write feet, FT. No square. We do square with the area.
An area.
Okay, so always find the missing sides first. Split your shape, the weird shape. Do not just add what you have. So that's the parameter. Now let's find the area. Again, this is not one rectangle. You can't just multiply 9 by 10. That would be wrong, okay? Unless you had a complete rectangle. So this is not 9 times 10. So we have to split it. We did. So basically, we're going to find 2 areas here. We're going to find A1. We're going to find A2, area 1, area 2. Once we add them, when we add them, the total will be this whole thing. That's what we need. We need the area of the whole irregular or composite shape. All right, let's do this on, well, actually, let's do them right here. So what's area 1? What, again, for a rectangle or triangle, we times the sides. Area 1, what is the area here? What is it equal to? What times what?
4.
Whoever has background noise, please mute your mic. Briefly, if you want to speak, unmute and mute back again quickly. What is the area of this box?
Is it 7 plus
Area, we need to multiply.
28.
28, so 7. This side times this side. Not this 10. This 10 represents the whole thing. So we're going to do 7 times 4, which is 28. What's the unit? What is the unit here, and how do you write it?
Feet or no,
Square feet. Okay, let's find the other area first.
square feet.
Well, let's actually find the other one as well. So this is area 1. What is area 2?
Okay, so 9
Plus 6.
Times 6, that's right. 9,
Oh, I
9
lose.
times 6.
6, that's right. It's not 2 because 2 is only this part. It's not 10 because 10 is the whole thing. We need exactly this one, 9 and 6 for this rectangle. So it's 6 times 9. What is 6 times 9?
54.
Okay. Finally, we add the 2. Okay, you can always do your math on the side. 60 will be 72. But again, since we don't use calculators, feel free to do this. I mean, not 72, but it will be 82. Okay, so you do your math on the side. And the unit again is feet, but with area, you have to square it. That's why we say square feet. When you talk about the areas of houses or how big is an apartment or a house is, we talk about square feet. Sometimes could be square miles if you have a mansion inside a huge piece of land, so you measure your stuff in square miles instead of inches. I mean, instead of feet. Okay, that's how you do a shape. It could be this way or it could be, you may see it that way as well. It may be given. So again, first thing you want to do, you want to split it either this way
Professor, I have a question.
or the other way. Yeah,
You don't divide it into 2?
we did.
No, okay. Yeah, because the formula. So
No, we don't divide. We want to put them together. So we want the area of the whole thing. The whole composite shape is A. So we add them, not divide.
okay.
You know, so this shape will be facing down or up, but anyway, so feel free to split it. Or it could be maybe something like this. You can split it this way or that way. It may also be probably something like this without this piece, without this one. Same thing here. So you want to split this here, for example. This is one rectangle, this is another one. Then you do just like we did. So it's up to you to divide the way you want. Either way, the result will be the same. Be careful when you find the missing sides. You will always have enough information to find the missing sides, but be careful to use the right sides, the right numbers to find the missing ones. That's a composite shape. What else?
Can you do one of those that you have just draw for me, please?
Let me
Because you how to do the shape and the size. Because this shape looks difficult right here.
Okay, let me look
Thank
up. Yeah. Let's see. Okay, I'm going to do a shape like this, but this time, but instead of this piece here, I'm going to use a triangle. We already used 2 rectangles. I'm going to use something like this with a triangle. It's more interesting. It's not in the book, but I think it's interesting to learn. So let me put it right here. So I'm going to need 2 shapes basically. I need a triangle. I mean, oops. This pen is so slippery. Maybe a piece like this. And another one that looks like this. something close to that. Almost there. Okay, that's pretty close. Let me see if we can make it perfect. All right, let's consider this. Just assume this is this matches here because I want it to be perfect. This has to end right here. I don't want it to go over. We probably just put another one. I'm going to delete this one here and grab a second one, shape, triangle. Okay, that's exactly what I wanted. As you can see, let's find both. First, the parameter, and then the area of this shape. Looks like a house or something, or an envelope, but it does not have one formula. We don't have a formula for this composite. Composite, again, because it's made of two shapes, or sometimes could be more. So you split this into as many shapes as needed, as many known shapes. Could be any of these or any known regular ones that we know the formulas to. So what are the two shapes? Usually the problem will not have this line. So you would have to split it. You have to use your imagination to split it into some known ones. So we have two shapes here, obviously. What is this one, the top one?
Triangle.
Triangle over what is this?
Rectangle.
Rectangle, that's right. And we do know both. We just did both earlier here. We can find area parameter for both. Let's put in some numbers here. Again, you will have all the numbers you need. And the missing ones, you will have enough information to find them. Let me use 5 here. 5. And we need the height. So I'm going to insert a vertical line for the height. Not exactly that. It has to be a vertical line, like I said earlier. You have to drop that vertically on the base of the triangle. For example, we're going to start from here, and we're going to insert this line, which is not easy to do. But you don't have to draw your shapes accurately when you do the homework. I just sketch it out. You don't have to. It doesn't have to be an actual thing. But you can still use a ruler and your graphing paper if you want. But in the computer, it can be a little tricky to insert that. Not exactly what I wanted. Okay. All right, just do this. It goes all the way here. Okay, and again, it has to be vertical, meaning you have a right angle here. Now let's call this the height. And give it a value of maybe 4. Okay, so now let's find, let me rewrite this here. So let's find all the missing, if any, parts. And once we do that, we can use those numbers to find the parameter and area. Let's start with the parameters. How do you find the parameter here? What do we need to do?
P,
So all around the shapes,
Multiply.
3, then
7,
then
then,
7,
nope. What's
then 3,
another 3 here?
and
Okay.
the last 7.
That's right. And no, the whole thing, not just the triangle, or not the rectangle. So
5,
3, continue here, that's right, 5, then
5,
5, and that's it. Not the inside, not the height. So the parameter is just the outside. You have 1, 2, 3, 4, 5. So what did we miss? Another 3. So 3 plus 7 plus this 3 before the 5. We missed the 3 here. Let me actually just rewrite it. Again, 3, 7, 3, then 5 and 5.
Do the numbers have to be in order like that?
Well, they don't have to be, but say
That's
it helps so you don't skip one.
That's
So-
30, right? 7 and 7 is 10. Another 7 and 7 and 3 is 10.
uh-huh.
Plus another
Another 10 here, right? And then add that would be. So we have the 10 here, we have the 10 and this.
plus 20.
Mhm.
I
Always.
thought it was 2 7, so it was only 1 7.
No, we're not doing this one because we're doing only the outside. So this is not a rectangle, this is a composite. So the parameter is just all around, not the inside. Okay, we're not going through this one here. Okay, this one is inside, so the parameter is just basically outside. Okay, so now let's find the area. What do you do to find the area?
So base,
That's right. So we have 2 shapes first. We have find this area 1. Find the area 2 of this. Okay, so we're gonna find the area of this, and then add them up to find the area of the whole composite shape. What is A1? How do you find A1?
A1 I think is 7 times
7 times?
7 times 3.
That's right. So A1 is a rectangle, 7 times 3.
That is 21
Plus,
plus 5. No. 4.
we need, this is a triangle. What is the area of a triangle?
7 plus 4.
No,
No, I think it's
5 times 4.
4 times 5.
that's right. Base times our height by 2. That would be, what's the base here?
4.
No, that's not the base.
7.
7
Times,
times 4.
What I said.
That's right.
someone has a noisy microphone. Makes a loud noise. Please fix that, or
Teacher, the first example, you say different.
say again?
The first example, you say different in triangle.
The 5th example you said?
Upstairs. Yes, is base and height.
Yes, base times height times 6. This one times this one divided by 2. Same thing here. So this is 7. Okay, same as this, so that's 7. And the height is given here is 4. And
Yeah.
okay, and then That's 21 plus 7 times 4. 2 for 28 by 2 is 14. We add this, you get 35. What's the unit again for the area here?
Square meters.
That's right. Square meters. Or m squared like this. Okay, so again, use your imagination when you have a composite figure. It's up to you to figure out a couple of figures or more based on the known shapes. You may not see this line again, so it's up to you to do the line. So I give you this one here, or in this case, you will have two rectangles, same way. That's pretty much how you find the area and parameter of various shapes, including the composite ones. Now let's move on to volume. Volume. We could call this, change this to area and parameter. Parameter. Number 2 will be about volume. Like I said, the volume is how much, let's say, air or liquid can you contain inside of a shape. The shape could be, for example, I don't know, baseball or basketball, could be a box, could be a cylinder. Cylinder basically is the shape of a can. Could be any shape. So the volume is the measure of how much of a substance, whether it's gas or liquid or water, whatever, can we fit into that container. So it has to be a container. It cannot be flat. You cannot put liquid on a flat surface. You can't measure it, but basically it would just spill all over the place, but you cannot measure it. So we need a regular shape or a container with certain dimensions or certain shape in order to find the volume of it. The most common, probably one of the most common shapes is maybe this one here, something like this. I'm gonna make a box. I'm just gonna make a box here. And basically a box is two rectangles, and then we're gonna join, just gonna join all these sides together. Okay, so that looks like a milk carton or something like that. So it has to have a volume. How many dimensions does this box have? How many dimensions?
Have 5.
Not 5.
3 dimensions.
3 dimensions. What are they? What are those dimensions?
Length, width, and height.
Very good. So the length is usually the longer one. The height, the W is for the width. So this is the base. So the base is a rectangle. So the base is flat, just like this. It has to have L and W. Okay, and the height goes vertical, of course, just like some extended up vertically. So this is the height of this. Every corner has the same thing. All these corners pretty much have the same thing. If you go here, same thing, the width, the length, the height. If you go over here, same thing. You have your height, you have the width, the length, and so on, all over the box. So we just need to write them once. We don't have to write them all over the place. The way you look at it is these two, this rectangle is facing another rectangle here. They're of the same side. Then this rectangle here on the left side is facing this one. They're of the same side. Then the bottom one is facing the top one. They're also the same. For the for the volume of this one, what do you think we do to find the volume of this whole shape? V for volume.
V.
Say again?
Yeah, B for volume, I think.
So when you find the area, you times 2 dimensions. When you find the volume, what do you do?
Left times
Left.
what, right?
That's right. We times all those dimensions. So length times
Point.
width times height. Volume only if it's a box, or if it's a cube. We'll talk about the cube in a moment. Just take the 3 and times them. For example, if this was 7, this was 3, this was, let's say 4. If this was 4, so we're just going to take all those and multiply them. So this will be 7 times 3 times 4. 7 times 3, that's 21, times 4. What's 3 times 24? 21 times 4?
84.
That's right, 84. And always we gotta have a unit. Let's make this m, or meters. Okay, if we times, to find the area, we times 2 dimensions, and it's squared. For the volume, we times 3 dimensions. What do you think? How do you think the unit is?
Square meter.
We multiply 3 times. We multiply 3 dimensions.
Oh, by 3.
By 3, that's right, it will be cubed. That's the international unit for measuring volume. Cubic meters or cubic inches or cubic whatever it might be, it has to be cubed because we have 3 dimensions that we multiply to get the volume, at least for this one here. So 84 square meters, or I mean, could be inches, could be anything. Meter cubes or cube meters, or inches or feet, whatever the unit is. You just put it to the 3rd power. Okay, so that's one common shape. Very simple, just times all the units, or all the dimensions. So that's 1. So basically your formulas here. For a triangle, that's the one for a triangle. And what else? Also the very first one we saw here. For the square, it's basically just the unit times itself, or added to itself if you find in the parameter. Okay, let's do another common shape. Yes, we're going to address the sphere and probably the triangle. I mean, not triangle, but the cylinder. Let's start with the cylinder first. You know, so let's write here. So I'm going to call this, this is a, so we did triangle volume, okay. So this is a rectangular box or solid. Okay, rectangular box, or you can say rectangular solid, but I'm going to use box, it makes more sense. Then we're going to use a sphere. Let me bring some shapes here to find out, to make a sphere. So the sphere is basically I mean not sphere, I'm talking about cylinder. It's basically the base is a circle. On the top is also a circle. Same dimensions. That's how easy it is to make a cylinder. Make sure you align these like that. Just about that. Okay, so now we just need a couple of lines here. And that's it. It will look like a sphere. Let's see if we can make that using 2 lines. Here's the first one. Just like that. Just happy little circles. And each line needs another happy friend right over here. And there you have it. You have your perfect looking cylinder. I'm sounding like Bob Ross. If you guys know who Bob Ross is. Does anybody know? Famous guy. He does something. Bob Ross. Have you heard of him? No?
No.
No, Professor.
You should check him out on YouTube. This is how he speaks. He paints and basically he talks like this, and he paints nature and mountains and trees and rivers. Every time he draws a tree, he would be like, "Oh, this is a little happy tree, and it's a friend right over here." And then he draws another tree. Bob Ross on YouTube. He has a bunch of videos. It's very relaxing and calming to watch him draw nature and stuff. Anyway, so this is my attempt at art. Okay, I can draw something like this. Now, okay, so this is a cylinder. A cylinder again is just 2 circles. This is the base. The top is also the same as this, and you have these 2 lines here. If you open up a triangle, if you open it up, if you cut it out, we cut it open, it turns into this. That's basically a cylinder. If you cut it, it turns into this. Imagine a sheet of paper. If you roll it, right? If you roll it and you make these 2 ends meet, it turns into a cylinder. So it's the same concept, basically. So this shape here is basically the width, and when you cut this open, this circumference turns into this length. Just so you know. So the area of a triangle is of a cylinder is very simple. So this has a height, and this circle must have a radius. Okay, the radius is just the distance from the center to the edge of the circle, or what do we call the whole thing? If radius is just from here to here, what do you call the distance from this all the way to here? Call it D. Starts with a D. The diameter, right? Yeah. It's basically the distance from here all the way to here, or half of it is R, or radius. So R means radius. Okay, for example, the radius would be from here to here. So this, the diameter. Okay, so diameter, or D, will be all the way this, but half of it is radius. So radius is, you could say, is half of the diameter. Okay, to find the area, or let's do, which one we're gonna do? Let's do the volume. Let's do the volume. So to find the volume, first we need the area of this and times it by the height. Just like you did here. See here how we find the area of this, which is L times W, and then we multiply it by the height. So the area of the base is basically LW times the height H. Same thing here, so we're gonna find the area of this desk, and we're gonna times it by H, the height. So let me give you the formula of that. So the area of the base, it's a circle. Let's call it area of the base is pi times r squared. Okay, you guys know what pi is equal to? Pi, the constant. What is it? 3 point. The famous pi is 314 times whatever r is. In this case, let's say give it a value, maybe 2. Okay, so we're going to times it by pi squared or r squared. So it means 2 squared. So r is 2. So 314 times 4. So that's the area of the base. What do we do now with this area? We times it by. So the area of the base is here. We're going to multiply it by h. That's right. Let's say h is maybe 10. And this will be let's say 314 times that by about 1256.
Teacher, please, can you repeat this part?
I'm sorry?
Can you repeat, please, when you say the base?
Yeah, so the base is a circle or a desk. So to find the area of circle, this is the formula. You times pi. This is a number known as pi, which is equal to this. And r.
This part, I don't understand this part is m. What is the letter P?
Pi is a number. It's a number associated with, usually when we find the areas and circumference of a circle, it's always equal to 3.14. I'll talk about it in another class. Pi, just remember, equals 3.14. And r squared is a radius, the distance from the center to the edge. Whatever it might be, you take r to the second power. So r is 2 to the second power is 2. And this is an area. We need a unit, for example, meters. So the area here, the base should be meters squared. Don't worry about the cylinders too much, okay? I understand. It can be a lot confusing, but someone mentioned it earlier. I wanted to address it. But don't worry about it too much. It's all right. Mostly you'll see probably this and triangles, not spheres, not cylinders. All you have to do now, just take this number, times it by the height. So A, the area, we're looking for the volume. The volume is basically, again, this times h, pi r squared times h. So this value here, we have it, 1256, times that by the height, which is again here, 10. If you times these, you'll get 12.6. The unit is m. Again, what is the power here for the volume? M should be not squared. So volume, we have to
Cube.
cube it. That's right. The volume, again, remember it's cubed. Inches, whatever it might be, has to be cubed. Area must be squared. That's pretty much it. Okay. Every shape has its own formulas and its own area, volume. There are more. If you need more of these, if you see them in the homework, you can find the areas as well. I mean the formulas: sphere, rectangle, pyramid, whatever it might be. And to simply take the formulas and plug the numbers into them. All these numbers will be given to you. So pi is 314, r, you can read it from here, h from here. Just put the numbers and multiply, just like we did here earlier with the rectangular box. You just write the formula and change or plug the numbers, L, W, H, all here, multiply them. That's pretty much it. Don't worry about this one too much, the cylinder. Just think about this one for now and the common shapes that we saw.